All right, hello again, geometry. Lesson 3 is about to begin. So, segment addition postulate, and we're going to use that to find missing segment lengths. To do segment addition postulate, you have to understand distance a little bit. So, the distance between any 2 points is a crazy, awful definition. Okay, but first of all, before I do that, the distance between any 2 points, which is a segment's length. So how do you find it? It's the absolute value of the difference of the corresponding numbers. Well, that sounds disgusting. I'm going to put it in other words for you. The length of AB, which is in the, not in the picture, but is the absolute value of A minus B. Again, that probably doesn't make it much better though. I'm going to use that formula to find the length of EF, okay, which is the example there. So all you're doing is, doesn't really matter where you start with one of the endpoints, -4. You subtract the other endpoint, 8, and you take the absolute value of it. So -4 minus 8 is -12. The absolute value of that is 12. So EF is 12. Now, you could just be smart about it also. Understand that that's 0 right there, right? So from E to 0 is 4, and from 0 to F is 8. So 4 plus 8, 12. Distance can never be negative, therefore 12. That's where the absolute value comes in. One little notation thing that I want you to notice is there's no symbol above EF. Okay, in the beginning it said find EF. It's not saying identify the segment EF, it's saying identify the length of EF. When there's no symbol above it, especially in this unit, we're talking find the length of that segment. All right, 2 segments with the same length are congruent segments. We're going to use that word congruent a lot in geometry. There is a symbol for congruence. It looks like an equal sign with a little squiggly above it. That means congruent. Okay. There's a picture here, A, M, and B. The markings right here, what do those mean? Okay. Those indicate that those 2 segments, AM and BM, have the same length. So if AM is 10, then MB is 10, which means that those 2 segments are congruent. AM is congruent to BM. Now, because there's a point that separates AB into 2 equal segments, we call that point, M in this case, the midpoint. And specifically, this is the midpoint of AB. It's the middle of that segment. Okay. Example. So this is the number line. It's a little different than what we just talked about. Find AB and BD. Notice no symbol above it. So I'm saying find the length of AB. Now you could do the definition and say, okay, AB, that's -8 minus -5. And then you would simplify that, -8, and that's minus a negative, so -8 plus 5, which is actually -3. So the distance is 3. So AB is 3. Now, rather than doing all that jazz, it might have been a good idea just to count, right? 1, 2, 3. Okay, you can do that. BD is 5, right? 1, 2, 3, 4, 5. Which segment is 8 units long? Well, I just started at A and went to B and got 3, and then I went from B to D and got 5. Together, aren't they 8? So from A to D, aren't they 8? Okay. What I just did there is technically segment addition postulate, which I haven't talked about yet, but that is an intro to segment addition postulate, which was basically common sense, right? Name 2 pairs of congruent segments. So I want 2 segments that are the same length, and I want 2 pairs of them. So very easy one is CD and DE. Those are each 2 units long, right? Now let's find more. Well, there's another very easy one. AB and BC are both 3 units long. There's probably more. I'm trying to find some here. So AC is 6. Oh, no, I guess not. So I guess those are the only ones. But They're the same, they're congruent because they have the same length, the same distance. Now we're moving on to segment addition postulate. Okay. If 3 points, let's call them A, B, and C, are collinear, and B is between A and C, so anywhere in between A and C, then AB plus BC equals AC. Now you're like, that's a lot of stuff. Well, think part plus part equals whole. So I just had on the previous example, I had a line, right? And I had A, B, and I think it was D on the previous page, right? And yeah, so this was A, this was B, and this one was D, which really doesn't matter. The lettering doesn't matter. It's just, I've got 3 points. And this, on this line, I have A, B, and D. Well, AB was 3 and BD was 5. So AB is 3 plus BD is 5. 3 plus 5 is 8. A's the whole thing. Think part plus part equals whole. So the part AB plus the part BD was the whole thing AD, which happened to be 8. Okay. So right away, I'm going to jump into something a little bit more challenging. Okay. Find AB and CD. Okay. So AB is over here. I'm going to put an X right there. Do I know anything about X? Okay. I'm looking at that and I'm seeing, well, I know X and 20 make this segment here. Do I know what that whole segment is though? I don't. So that's not going to help me. What am I going to do? Well, let's look at CD. And I want you to understand this. In geometry, if I say find A, B, and CD, you don't have to find them in that order. I'm going to go over here and do CD first. And I see, hopefully you do too, that B and D is 36 long, right? Now I have BC, right? So BC is 20 plus CD equals BD. Make sure you look at those letters and see what I'm doing there. BC plus CD equals the whole thing BD. So now I'm going to replace BC with what I know, 20. CD is what we're looking for. And BD is 36. And I have a very simple equation, subtract 20, and I get that Y or CD equals 16. Okay, now how's that going to help me? I'm actually going to erase all this, leaving the other stuff there. Well, I've got the whole thing is 54. Now, segment addition postulate doesn't just apply to 3 points. I can do AB plus BC plus CD equals the whole thing of AD. Well, AB is what we're looking for. BC is 20. CD we just found to be 16. And AD we know is 54. You should be able to solve that now. 20 plus 16 is 36. Subtract it, and you should get 18. So AB is 18. Now you can find AC, right? Because AB plus BC equals AC. Well, AB I just found, it was 18. BC is 20 equals AC, which is 38. All right, so that was a pretty good use of segment addition postulate there. Now, it's not all just going to be numbers. You could have equations as well. We're actually going to see equations a lot. Find the value of X and show the equation you use. Okay, so let's look at this picture. And the picture includes the given. Make sure you see the given. Very important here. So what I see is ds plus st equals dt. Well, let's replace stuff that we have. So ds is 2x minus 8 plus st, which is 3x minus 12, equals dt, which I told you was 10. Now I can solve that, right? 3x plus 2x is 5x. -8 plus -12 is -20. Add 20. I get x equals 6. Now, find ds and st. Should be pretty simple. All I'm doing here is plugging 6 back in for x. So 2 times 6 minus 8 would be 12 minus 8, which would be 4. And I can plug it in, or I can just do my basic math. If the whole thing's 10 and ds is 4, then st has to be 6. But just to make sure, 3 times 6 minus 12 is 18 minus 12, which is 6. Okay. Now, next problem. Not always going to follow the exact same pattern that I just did. Look at my given. C is the midpoint of AB. There's that word that I introduced on the front side. C is the middle of AB, which means that these two segments are equal. Notice I don't know the length of AB. It's not there. I didn't give you that like I did in the previous problem. Here's what I see a lot of people do. They go, oh, 2x plus 1 plus 3x plus minus 4. And they write equals, and then they're like, I don't know what this is. There's nothing that it's equal to. I can't do this problem. Well, look at it a little closer. The midpoint of AB means that those two are equal. It means that AC is congruent to or equal to CB. And there's where you get your equation. 2x plus 1 equals 3x minus 4. Subtract 2x, I get x minus 4 equals 1. Add 4, I get x equals 5. Now, find AB. Here's what a lot of people are going to say. They're going to plug it in and get 11. AB is not 11, though. Okay? Because I said AB. So that's the whole thing. This is 11, right? 2 times 5 plus 1. So 10 plus 1 is 11. 3 times 5 is 15 minus 4 is 11. So the whole thing is 11 plus 11, or 22. Okay. And that's segment addition postulate, which has a lot to do with what we are going to do in the next lesson, which is angle addition postulate. Okay. So that's it for this video.